In the first part of this example, we want to define the total number of unknowns in this circuit and determine appropriate variables for mesh analysis using constrained loops. When we use constrained loops, I'll use the trick of shorting voltage sources and opening current sources. So this voltage source becomes a short circuit. This resistor is unchanged. I open up this 1 amp current source. This resistor, the 4 ohm resistor, also remains unchanged. The 3 amp current source becomes an open circuit. And these two resistors here remain as is. That process leaves me with two enclosed non-overlapping areas. One's there and one is here. The number of mesh currents is simply the number of these areas. So we have two mesh currents. That means we'll have two unknowns. Now let's define appropriate variables and constrained loops for this circuit. The mesh currents, which are our unknowns, just go around these enclosed non-overlapping areas. So this will be one mesh current around here. I'll call that I1. And the other mesh current goes around this area. I'll call that I2. If we do this process, none of our mesh currents will account for the current sources. The constrained currents account for those sources. So for this 1 amp current, I think I'll create a constrained loop here that goes in this direction, and it has an amplitude of 1 amp. Up here, I think I'll create a constrained loop that matches the magnitude and direction of this 3 amp current. That'll be 3 amps. So those are all the variables and the constrained loops that I need to analyze this circuit. It only requires two equations to determine the two unknown mesh currents. Now let's define unknowns and variables for this circuit if we don't use constrained loops. So if we don't use constrained loops, all of the enclosed non-overlapping areas, if we include the sources, define mesh currents. So this will be an enclosed non-overlapping area. This will be an enclosed non-overlapping area. This is enclosed and it doesn't overlap any other area. And this is also enclosed. It doesn't overlap any of the previous areas. So we have 4 areas. That means we'll need 4 mesh currents. In the process of doing this, though, we've also created unknown voltages across current sources. We have 2 current sources, so that will result in an additional 2 unknown voltages. So adding up all of these unknowns means that we'll actually have 6 unknowns, and we have to write 6 equations to solve for those unknowns. Now let's actually define variables to correspond to these unknowns. First, we have 4 mesh currents. I'll call this one I1, I'll call this one I2, this one's going to be I3, and this one's going to be I4. Those mesh currents are going to go around the perimeters of the enclosed non-overlapping areas we defined up here. Now we also need our voltages across the current sources. So I need to define an unknown voltage here across the 1 amp source, V sub x, and a voltage here across the 3 amp source, V sub y. The polarity is arbitrary. You just have to make sure that you choose something and stick with it. So those are our 6 unknowns that we need for our 6 equations.